Unit 5, Relationships in Triangles. Unit 5, Day 3. What should I know after this lesson? Well, you will know if three segments can form a triangle. You will know how to determine a range of possible values of a third side of a triangle if I'm only given two sides. You will also know which side is the largest in a triangle based on angle measures. First thing I want you to think about, can any three segments form a triangle? Now that you've had a chance to think about that question, take a look at the three segment lengths here. Could I arrange those to make a triangle? Because a triangle has three sides. Take a look over here at the red segment lengths. Could I arrange those to make a triangle? That'll help us answer the question, can any three segments form a triangle? Well, I guess after seeing the triangles, we can answer the question, can any three segments form a triangle? Looks like the answer is no. When I put my three sides together from the left, the black sides here together, came up a little short. So any three lengths can form a triangle? Absolutely not. Take a look at the red side lengths. When I put those together, one is longer than the others. So there's an overlap. So it's not able to make a triangle with those three side lengths. So the question is, can any three segments form a triangle? Absolutely not. So that brings us to our theorem here, which is called the triangle inequality theorem. It states a triangle exists if the sum of the two smaller sides is larger than the third side. So we talk about equality and we talk about equal, but here the two smaller sides must be greater than the third side. So let's put it to work. Determine if the following side lengths could form a triangle. And we're going to prove our answer with an inequality. Is it a triangle? Well, according to the theorem, you want to take the two smaller sides, so that would be 8 and 17. So we need 8 plus 17 must be greater than 24. That's the triangle inequality theorem. So 8 plus 17 is 25. The question is 25 greater than 24? Yes. So can those three segments form a triangle? And the answer is yes. Let's take a look at number 2. Let's take the two smaller sides, which are 3 and 3. And what we're going to do is we're going to do 3 plus 3, two smaller sides, must be greater than the third side. So 3 plus 3 is 6. Is 6 greater than 7? No, it's not. So could those three segments form a triangle? No, they can't. So this is what you're going to do in this section when you're being asked, can it form a triangle? Go ahead and take the two smaller numbers and add them up, and it should be greater than the third side. So in this section, you're going to be given two sides, and so you need to find out the possible lengths of the third side. So let's go ahead and write some notes over here. It says let x equal the third side. So we're going to have an inequality. So we're going to have a, which is going to be the smallest it can be, is going to be less than x, less than b. So what we're going to do to find our smallest side, we're going to take the difference. See if I can write that out. And that's going to give us our smaller side. And for our larger side, we're going to take the two sides that we're given and we're going to add them up. So we need a sum and we need a difference, and that's going to give us our range of the possible third sides. So let's go ahead and read the directions. Given two sides of a triangle, you can set up an inequality using the sum and difference to show the what? the range of possible third sides. So we have 14 and 22. So what we're going to do is we're going to add 14 and 22. So 14 plus 22, and we're going to get 36. We're going to take 22 and subtract 14, and we're going to get 8. So our range of possible third sides is going to be greater than 8. However, it must be less than 36. So that's our inequality. So if we wanted to put a triangle together, if we have a side that's 14 and a side that's 22, we can make a triangle as long as that third side is bigger than 8 but less than 36. So this is what we're going to do when we're given two sides. We're going to make a range. Alrighty, so let's look at number 10. First thing we're going to do is we're going to add 31 and 28. And we get 59. Next, we're going to subtract 28 from 31, and we get 3. We're ready to put our range together. Always put your smaller number on the left. So 3 is less than x is less than 59. So that third side, it can be bigger than 3 and less than 59, and it will connect to make that triangle. So you practice some for number 11 and 12. All right, is this the range you got? Great. So here's a practice problem for you to think about. It says check all possible sides for triangle with sides 8 and 10. So take a look over here. Let's just say this is our triangle. Well, it's the triangle we want to form, and we already have two sides. And so we want to know the possible third sides. Now this triangle could be acute, it could be right, it could actually be obtuse. Take a look. But whatever the case, we need to figure out all the possible third sides. So what do we do when we're trying to find the possible third sides? Yes, we set up a range. So we're going to do 8 plus 10, which gives us 18. And we're going to do 10 minus 8, which gives us 2. So our range is going to be between 2 and 18. So we're going to go through and check all that would apply. Could 2 be a possible side? Well, this is 2, and since 2 is not greater than 2, that would not be a possible side. We need our third side to be bigger than 2, not equal to. Would 12 fit in this range? Absolutely. 12 is bigger than 2 and less than 18. Would 16 fit in this range? Absolutely. 17.5? Yes. What about 20? Nope, that side is too big. So this is what we're doing when we're given two sides and trying to find a possible third side. When could we use this in life? Oh, I'm glad you asked. So here's a diagram that shows Jane's house, which is this vertex, Amber's house, which is here, and there's 14 miles between Jane and Amber's house. And then we have Jane's house and Luke's house, and there's 6 miles between Jane's house and Luke's house. Well, right here between Amber's house and Luke's house, we don't know how many miles it is. But the question is it really 25 miles between Amber's house and Luke's house? Because Jane seems to think that it's 25 miles between Amber's house and Luke's house. So we need to figure out, is that true? So what we're going to do is we're going to use the triangle inequality theorem, and we're going to do 6 plus 14, which equals 20, and then we're going to do 14 minus 6, which is 8. So our range is going to be from 8 to 20. So is it really 25 miles between Amber's house and Luke's? No. Unfortunately, Jane was not telling the truth. So this is just one of the ways we can use the triangle inequality theorem. Alrighty. In our last concept, we're going to talk about ordering sides and angles. We're going to be given limited information, but we are going to be able to answer the questions using the information that we are given. So here I'm given information about the sides, and the directions say ordering angles. So when we're ordering angles, the smallest angle is always opposite the shortest side, and the largest angle is always opposite the longest side. So let's take a look and let's find the smallest angle. Oh, we don't have information about angles, so let's go and find the smallest side. So the smallest side is 7. What's across from 7? Go across. 7 is across from angle A. So what is the largest side? The largest side is 13. What is 13 across from? It is across from B. So 13 is across from B. Our middle side is 10, and it is across from what? C. So in order to list the angles from least to greatest, we have angle A, angle C, and angle B. And see, we weren't even given anything about angles, but we used the sides to determine the information. So let's practice. Order the angles from least to greatest. I recommend 2 things: that we write out what we're given in order from least to greatest. So we are given 17, 20, and 24. What am I given? I am given sides. So we're going to start at 17, and we're going to go across from 17, and that is angle M. We're going to go across from 20, and that is angle P. We're going to go across from 24, and that is angle N. So list the angles in order from least to greatest. It's angle M, angle P, and angle N. It said angles, so that is 1 letter or 3 letters. There we go. This one says order the angles from greatest to least. So let's write down our biggest number, 11. The next side is 9, and then the last is 8. Let's go to side that's represented by 11, and let's go across. Make sure you draw your arrows, and that will be C. Let's go to 9 and go across, and that would be B. Let's go to 8 and go across, and that would be D. So when we get ready to label our angles or list our angles in order from greatest to least, we would have angle C is the biggest, angle B is next, and then angle D. Notice I'm not doing them all. I'm giving you something to practice and to work on. Let's take a look at what's next. Whoa! In this case, we will be ordering the sides in order from least to greatest, or either from greatest to least. So the shortest side is always opposite the smallest angle. The longest side is always opposite the longest angle. So what we're going to be doing again is drawing arrows across from opposites. So what does it say here? Order the sides from least to greatest. Well, we don't have any information about the sides, but what do we have information about? We have information about the angles. So we have one angle is 103 and one angle is 42. We're missing an angle, but could we figure out what that angle is? Absolutely. So now that I have my given information, I'm going to write the numbers in order from least to greatest. So my smallest number is my smallest angle, which is 35. Then I have 42, and then I have 103 degrees. Well, let's go across from 35, which is at F, and it goes across to side ED. We're working with sides now, and sides we write with 2 letters. We're going to go to 42. 42 up here at E is across from DF. And last but not least, 103 is across from EF. So we list the sides in order from least to greatest, and we have ED, and then we have DF, and then we have EF. And we just listed the sides in order from least to greatest. Let's do some more practice. Order the sides from least to greatest. So first we're going to have to fill in some missing information. So the angles that we are given, 31 and 57, and we had to figure out the last one, 92, because all the angles add up to 180 in a triangle. So we're ordering the sides, so across from 31, which is angle J, across from that is KL, side KL, across from 57, which is angle L, across is KJ, and last but not least, angle K across from angle K is JL. So look at us. We just wrote the sides in order from least to greatest. One more practice. Order the sides from greatest to least. We're still missing information, so let's figure out what that missing angle is. 44 degrees. They want us to list it from greatest to least, so we're going with 82, 54, 44. We're listing sides, that's 2 letters. 82 is across from side XZ. 54 is across from side YZ. And 44, last but not least, is across from side YX. So what do? We listed the sides in order from greatest to least. So summary. How do we determine if 3 sides can form a triangle? What do? We take the 2 smaller sides and you add those 2 smaller sides, and the sum should be greater than the third side. It can't be smaller, it can't be equal, it must be greater. Second thing, if we're given 2 sides, what's the range for the possible third side? So we're going to do a sum and difference. We're going to set up a range where we have A is less than X is less than B. And we'll get that when we add the 2 sides. When we subtract the 2 sides, it'll tell us the smallest it could be and the largest it can be. Last thing, how to label sides from greatest to least when you are given information about the angles. Okay, so the first thing you want to do is, yes, write angle measures from greatest to least. And once you have that, draw arrows to the opposite side. And once you write those down, you will have the sides in order from greatest to least. So that concludes our lesson, Unit 5, Day 3.